Hello everyone, my name is Bapi Hamed and welcome to my YouTube channel. So guys, in this video we'll be implementing one amazing project called Automatic License Plate Recognition. So here we'll be using YOLO V9 and Easy OCR. So here first of all we'll be detecting the license plate, then we'll be extracting the number from that particular license plate with the help of Easy OCR. If you don't know about OCR, OCR is nothing but optical character recognition. So with the help of OCR we can easily extract any kinds of text from an image or video. So in this video, to perform the object detection, I'll be using YOLO V9 model. So here we'll be first of all training our custom data. So here we'll be using this car license plate data. Then we'll be fine tuning that state of the art YOLO V9 model. Then after that, we'll be applying OCR on top of it to extract the information from the license plate. So guys, here you can see I already prepared one collab notebook for you. So here, first of all, what you have to do, you have to first of all connect this notebook and make sure you've selected runtime as a GPU, because here we'll be doing the fine-tuning operation first of all. Okay, this YOLO V9 model, then we'll be doing the inference on top of it. That is the idea. Now I already connected with my notebook, and let me show you the dataset, guys. The dataset actually I'm using. So this is the data, guys, and this dataset is available inside RoboFlow Universe. RoboFlow Universe is one of the amazing platforms. So here you will get all kinds of computer vision related data. So if you need any kinds of data, so try to search here, you will get all kinds of data here. So here I'm going to use this particular data, guys. This is the car license plate data. You can see this is the car license plate data. So here you can see we are having different cars with respect to the license plate as well. I will show you how we can connect with the RoboFlow Universe and how we can get the data, okay, inside our Google Colab. So as of now, first of all, let me execute this particular line. So this will give me the GPU configuration. So I'm using Tesla T4 GPU. Now, first of all, I will set the current working directory. That means I'm inside content directory. You can see this is my current working directory right now. So the first thing what I have to do, I have to clone the YOLO V9 repository. So first of all, I have to clone it. Then I have to install the requirements. Okay, so it is having one requirement.txt file. I have to install that particular requirements. So see, this is the requirement.txt I have to install. So let me install. Now, I already told you we'll be using RoboFlow Universe to download the data. That's why I need to install RoboFlow as well. Then we'll be downloading some pre-trained model, okay, from the internet. And these are the pre-trained model are available inside YOLO V9. So let me download all of them. Now, if I refresh left hand side, you can see the wait folder. Inside that all the model has been downloaded. Now, if you want to list down, you can also use the ls command to list down all of the model. Now I will redirect to my YOLO V9 folder. Now inside that I'm going to download the data. Okay. Now how to download the data? So just come here, click on the download project. Now here you will see one option, download dataset. Just click on download dataset and see this dataset is already annotated. Okay, I don't need to annotate this dataset. So here I can directly download the format. Let's say I want to use YOLO V9 model. I'll select the YOLO V9 model and I'll directly use this particular data. So I'll just try to select YOLO V9, select the show code and continue, and copy this code snippet and try to paste here. Okay, so now it will download the data from the RoboFlow Universe. But before that, you have to give one access token here. So to get the access token, visit the link and make sure you log in with your account. Okay, so you should have account in the RoboFlow, then you will be able to get this particular token. Now I'll select my workspace. Now I'll generate the token. This is the token, guys. Just try to copy and here let me paste. Now if I press enter, it will authenticate, then it will download the data from the universe. Now if I refresh, see this data has been downloaded. Now if you see the data.yaml file, it is having only one class, which is nothing but license. Fine. And inside training folder you have the image as well as the labels. Okay, I think you know what is the format of YOLO. I already discussed this part. Now I can start the training, guys. To start the training, you can execute this train.py. So here is the train.py. Inside that they have written all the code. You don't need to change anything. Only you just need to give some parameter like batch size, number of epoch, image size, okay, device. So device is equal to 0. That means I want to utilize my GPU. I am only using one GPU. That's why device is equal to 0. If you're using multiple GPU, you can also give the GPU ID here. Now, as of now, I'll be training 25 epoch. You can also increase the epoch size. Let's say if your model is not performing well, in that case, you can increase the epoch size. Now here I'm giving my data location, my data.yaml file location. So here is the data.yaml. So it is available inside my dataset.location data.yaml. Okay, this is the location. Now here I'm specifying the weights. That means which model I want to fine tune. I want to fine tune this Galaxy PT model. It is available inside weight folder, Galaxy PT model. Fine. Now I can start the training, guys. Now I'll click on the training. Now training may take some time. So I will pause the video. Once training is completed, I will come back. So guys, you can see training has started. You can see it has loaded the training data, validation data. Now see, training has started. My epochs is running. So let's wait. Once training is completed, I will come back. So guys, as you can see, my training is completed, and this is my MAP score I'm getting. That means if your MAP score is close to 1, your model is performing well. And if it is close to 0, that means it is performing not well. Okay. We can also validate our model. I'll tell you how we can validate. But before that, let me show you. It will create a folder called runs. Inside that, it will save all the artifacts that's inside train experiment. See, inside weight, this is the weight actually we have trained. Okay, base.pt, this is my weight. We'll be using this particular weight. Apart from that, it has also saved different matrices. Okay. Now let me plot and let me show you. These are the matrices. Like the entire loss and accuracy, we can see. Now I can also list down this folder. So these are the files it has generated. Now if you want to visualize them, you can just simply execute this code. It will visualize this result.png, and inside that you are having all the graph you can see. Now losses is decreasing as per your epochs is increasing, and this MAP is increasing as per your epochs is increasing. That means learning was good, but sometimes actually you can see the zigzag issue because you need to increase the epoch size a little bit. Okay, because I only trained 25 epochs. It's not actually a good epoch size. Whenever you are training your actual model, try to at least train 300 epoch. Okay, you will get a good model. Now, if you want to visualize the confusion matrix, this is the confusion matrix. So this is the confusion matrix. We are having only one class license. Okay. Now, if you want to see the batch images, so you can execute this code. It will show you some batch images. See, these are some batch images. Okay. Now, different license plate image we are having. Now, let's do the validate my custom model on top of my test data. So here you can see I'm using my base.tt model. On top of that, actually, I'm running the validation. Okay, so there is a file called valid.py. Inside that, they have written all the code. How to perform the validation, all everything they have given. Now let me validate it. So it will show me the validation score. So once execution is completed, you will see the validation score. See, this is the MAP score, mean average precision, and it's 0.97. That means it's almost good. Okay, it's performing well. And now you can perform the inference with your custom model. So here I'll be taking my test images. Okay, and on top of that, I'll be predicting my model. So let me define my base.pt location, and this is my testing image I'm getting from my dataset location. Now let me do the detection. And they have already created one file called detect.py. Inside that, they have written all the code. Okay, like how to load the model, how to perform the detection, how to visualize, everything they have written. So you don't need to worry about. Only just need to execute and set these are the parameters. That's it. Now see, detection is completed. Now if you want to see them, go to the runs folder again. If I refresh, inside runs, you can see it has created detect folder. Inside that, it has experiment. Now see all the prediction. Now if you want to visualize, I can execute this code. It will visualize all the example. Let me show you. See, this is the visualization. Now it is detecting the license plate. Okay, you can see. But some of the image actually it's not good because I told you need to increase the epoch size a little bit. You can also open it up. See, okay. Detection is pretty good. You can see 91% confident it's a license plate. Fine. Now let's see how we can perform on top of the video. So I have one video file, guys. So let me just upload it here. So let me show you the video file. So this is the video, guys. So this video I'll be uploading, and on top of that, I will perform the detection. So I'll upload inside my YOLO v9 folder. I will upload. This is the video card.mp4. Let me upload it. So my video has updated. Now you can see this is the video. Now we'll be running this model on top of the video. Now see, I'm running the detect.py only. And the confidence score I have taken very less because I want to detect all the, let's say, license plate present in that video. You can also decrease and increase it. It's up to you, but I'll suggest just keep it 0.5. Okay. As of now, I just only trained 25 epoch. That's why I'm keeping confidence score 0.1. Now device is equal to 0. That means I want to run on my GPU. And this is the weight location. This is my base.pt, and source is equal to my video location. Okay, card.mp4. Now let me execute and let me show you. Now, first of all, what it will do, it will convert to frame, actually image frame. and it will try to detect, and it will again convert to the video. See, you are having 631 frame, okay, in this video. So see, execution is completed. Now if I want to see the results, so just refresh, go to the runs folder, detect folder, experiment 2. Now this is the mp4 video, just try to download it. Now see, it has downloaded. Now let me open it up. See, now I'm getting the detection. See, it is detecting perfectly. But here we have done the detection. Now what I have to do, I have to extract the, let's say, numbers, okay, numbers from the license plate. For this, we'll be using easy OCR. We'll be applying easy OCR to extract the information. So let me show you how we can do it. I'll close this. Now see, this is the code, guys. First of all, let me install the easy OCR. Now see, I just did a small modification in the detect.py. See, whatever detect.py we are having now, I'm using the same code, but inside this code, actually, I added some of the functionality. Let me show you. So this is the file I prepared, ANPR. Let me open it with my Visual Code Studio. See, the same detect.py I'm using, only the change I have done, I imported EasyOCR and CV2, and this function I have created. Okay, this function I have created called perform OCR on image. That means whatever detection I'm getting, okay, from my detection model, I'll pass this detection image here, and it will extract the information. That means whatever text actually it is having, then this results actually it will return. Okay, this is the idea. So this is a simple function I have written, and this function I'm calling after doing the detection. Let me show you. So if I go below, so this is the line, I think. See, easy OCR code. Okay, so here actually you can see I'm calling this function. So I'm whatever detection I'm getting from my detection. See, this is the detection image I'm getting, and this is the coordinate point. I'm extracting the text, and I'm adding this text in the label, and I'm passing to the annotator. Okay, and what this annotator will do, it will show that text on top of the bounding box. Okay, so this will show that text. So that is what actually I'm doing. This is the small modification I have done. Apart from that, the same code I'm using. Okay, now let me upload this file. So what I will do, I will upload this file inside my YOLO v9. Okay, v9 folder. I'll open, upload. So here is the file. I'll try to upload. No need to worry, everything would be shared in my description section. So from there you can download. Now see, ANPR.py I have uploaded. Now this is the file. Now we have to execute this file, and the same confidence code device, everything you have to give your model location, and source is equal to your image. Now see, if I execute the code, now it will first of all actually detect, then it will extract the information from that particular detection. Okay, it is giving me one error because here I've given experiment 2. It should be experiment 1 only. Okay, should just experiment. Now I think it should work. So see guys, my detection and extraction is done. Now if I want to see the results, I'll go to the runs folder again, detect, and the last experiment 4, and download this video. Now it is downloaded. Now if I open it up, you will see the detection as well as the recognition. You can see it is extracting the numbers, okay, from the license plate. So yes, that's how actually we can perform automatic license plate recognition with the help of YOLO v9 and easy OCR. So yes, this is all about from this video. I hope you liked it. So please try to subscribe to my channel and share this video with your friends and family. With that guys, thank you so much for watching this video, and I will see you next time.